Good morning, students. Today we will discuss about some terms related to nuclei that are also common to chemistry: isotope, isobar, isotone, isomers, nuclides, etc. First, let me finish what is isotope. Isotope means the element having same atomic number but different mass number. Atomic number means Z must be same, but atomic mass number capital A must be different of an element X, Z, A. This is atomic number, this is mass. The element having same atomic number but different mass number are known as the isotope. There are some elements in the periodic table which have more than 2 isotopes. For example, hydrogen has 3 isotopes. One is your 1H1, another is your 1H2, another is your 1H3. This is hydrogen, this is deuterium, this is tritium. Means every element having the same atomic number 1 but different mass number, that is 1, 2, 3. Therefore, these are known as the isotope of hydrogen atom. Next part comes to the isobars. Isobar is just reverse of the isotope, means different atomic number but same mass number. Some elements, the element having same mass number but different atomic number is known as the isobars of the element. There are some examples like 1H3, one of the isotope of hydrogen, 2He3, another isotope of helium, because helium has 2 isotopes. One is 2He3, another is 2He4. The isotope 2He3 is isobar with the isotope of hydrogen 1H3, means same mass number but different atomic number, that is 1, 2, but mass number is same 3. Another is your chlorine and sulfur. Chlorine 17Cl37, sulfur 16S37, having same mass number but different atomic number. Mass number same, that is 37. Another example is your isotope of calcium 20Ca40 and isotope of argon 18 argon 40. That is same mass number, that is 40 but different atomic number, that is 20 and 18. You have to remember some examples of isobar. Give one example, 2 example or 3 example of isobar. Then you can write these examples. Another is your isotone. Before going to isotone, let me finish what is nuclide. Nuclide means the representation of an element in the terms of its atomic number and mass number is known as the nuclide. Means X, let X is an element and Z is its atomic number, capital A is its mass number, then the element can be written as ZXA, means this is the nuclide. This is known as the nuclide. Then what is the definition of isotones? The nuclides having same number of neutrons are known as the isotones. Same number of neutron. Neutron, how the neutron is calculated? Z is the number of protons and A minus Z is the number of neutrons. A minus Z means mass number minus atomic number represent the number of neutrons present in the element. What are the examples of isotones? Means neutron, number of neutron must be same, means A minus J number is same. That is one of the isotope of hydrogen 1H3 and helium 2He4 are 2 isotones. Why? Because they have the same number of neutrons, means 3 minus 1, that is 2, 4 minus 2, that is 2, both having the same neutron, that is 2. Another example is your 17 chlorine 37 and nitrogen K potassium 19 potassium 39. Means chlorine 37 and potassium 39 means its its number of neutron is 37 minus 17, that is 20, and its number of neutrons of potassium is 39 minus 19, that is 20. Because its mass number is 37, atomic number is 17, 37 minus 17 means A minus Z is 20, and also for potassium A is 39, Z is 19, A minus Z, that is 20. Therefore, chlorine 17 chlorine 37 and 19 potassium 39 is the isotopes, whereas 1H3 and 2He4 are the isotopes because they are the same neutrons. And this is the some terms related to nuclei. Next is your nuclear force. What is the definition of nuclear force? Generally, in case of a tiny nucleus, it constitutes both protons and neutrons. Means, nuclear force definition. The nuclear force is a strong attractive force that binds protons and neutrons together inside a tiny nucleus. Tiny means very small nucleus. Proton is a positive charge particle, neutron is a neutral charge particle, therefore it is always attractive in nature. Therefore, the nuclear force is the strongest force. What are the properties of nuclear force? First is it is very short range force because the distance of the separation between the proton and neutron is not very large. It operates in the range of 2 to 3 Fermi. Means first property is that nuclear force is a strongest or short range force. Short range force means the nuclear force can operate within the range of 2 to 3 Fermi. Means 1 Fermi, that is 10 to the power minus 15 meter. Means 2 into 10 to the power minus 15 meter is the separation between the proton and neutron. Then the nuclear force also can be generated. Or between 2 to 3 means up to 3 into 10 to the power minus 15 meter range. Second property is your strongest force. Nuclear force is generally a strongest force. If we will compare it with the gravitational force, electrostatic force and the nuclear force, then the ratio between them, if gravitational force is 1 times, electrostatic force is 10 to the power 36 times, but nuclear force is 10 to the power 38 times. Means ratio is gravitational force is to electrostatic force is to nuclear force equal to 1 is to 10 to the power 36 is to 10 to the power 38. This is the required ratio between the gravitational force and electrostatic force and nuclear force, from which we can identify, we can confirm that the nuclear force is the strongest force. Third property is your charge independent. Nuclear force is a charge independent, means it does not depend upon the charge of the particles that takes part in the nuclear force, means proton and neutron. Fourth property is your spin independent. Spin dependent. Nuclear force is spin dependent. Spin dependent means in the nucleus, protons and neutrons are bind together, around which electrons are revolving on a specific orbits. Means nuclear force is charge independent, but electrostatic force is charge dependent. Whenever it is positive charge, both are repulsive force when it is positive, negative charge, attractive in nature, but in nuclear force, just like electrostatic force, it is charge independent. But spin dependent is the nuclear force. This is the definition of the nuclear force, and these are the properties of nuclear force. First property, it is a short range force. Second property, it is strongest force. Third property, charge independent force. Fourth property, it is spin dependent. Next part is your mass defect. What is the concept mass defect? Generally, there is a concept rest mass, which is also discussed in the mechanics chapter. Rest mass means mass of a body when it is at rest with respect to observer. Means when the body is at rest, then the mass of the body is known as the rest mass. But actually the substances which are moving with the speed of light means that cannot come to the rest state. Its rest mass is zero, like photon, gamma rays, etc. having rest mass is always zero, because gamma rays or photon moves with the speed of light, that does not come to the rest. Therefore, the rest mass of an object is the mass of the object which is at rest with respect to an observer. The rest mass of photon always zero, because photon moves with the speed of light. But what is mass defect? So generally in a nucleus, Z represents the number of protons and A minus Z represents the number of neutrons. That also already we have discussed in the previous sections. Let MP, like this MP, mass of each proton. Each proton has mass MP. And Mn is the mass of each neutron. Let MP is the mass of each proton, Mn is the mass of each neutron. Then what is the total mass of proton? If Z is the number of proton and MP is the mass of each proton, then the total mass of proton becomes ZMP. If Mn is the mass of each neutron and A minus Z is the number of neutrons, then what is the mass of total neutron? That is A minus Z into Mn. A minus Z into Mn. Now, what is the total mass of nucleus? Mass of proton plus mass of neutron means ZMP plus A minus Z Mn. The difference between the mass of the nucleus ZMP plus A minus Z Mn and the rest mass is known as the mass defect. Rest mass, that is also given in the question. Z, number of proton and number of neutron, you can calculate from the symbol or nuclide of the element. And MP and Mn, mass of each proton and mass of each neutron, always take in atomic mass unit. Then mass defect, which is denoted by delta M, that is equal to mass of proton plus mass of neutron minus capital M, which is rest mass. That is known as the mass defect, change in mass. Mass of nucleus means mass of proton and mass of neutron minus the rest mass, capital M. This is known as the mass defect, which is always denoted by del M. This is all about the mass defect, which is related to binding energy. Also, we will discuss the binding energy. Next part is your binding energy. What is the definition of binding energy? The name binding, but it is the amount of energy required to split off the nucleus into its constituents, protons and neutrons. Means the amount of energy required to break up the nucleus into its protons and neutrons is known as the binding energy. Generally, it is denoted by capital B. If we write mathematically, then according to Einstein's mass energy relationship, binding energy is given as mass defect into c square. But according to Einstein's mass energy relationship, E is equal to mc square. But in case of binding energy, the Einstein's mass energy relationship B is equal to delta mc square, where B is the binding energy and delta m is the mass defect, c is the speed of light. And the important thing is that binding energy is always calculated in mega electron volt. Now, B is equal to delta mc square. B is equal to delta mc square, but delta m is equal to ZFB plus A minus ZMN minus capital M. Therefore, binding energy B is equal to ZFB plus A minus ZMN minus capital M whole into c square. It is calculated in mega electron volt, and this is the required formula for binding energy. Next, let's discuss a question. Calculate the binding energy in mega electron volt of nitrogen 7n14 nucleus. These are the given that rest mass of capital N is equal to 14.00307 U, mass of proton is equal to 1.00727 U, mass of neutron 1.0084 U atomic mass unit. These are the given things. Then what is its mass defect? Delta M equal to ZNP plus A minus ZMN into delta M is equal to ZNP plus A minus ZMN minus capital M. ZNP, Z, how much are Z? 7. What is the value of A minus Z? Also 14 minus 7, 7. Now delta M is equal to 7 into MP 1.00727 plus A minus Z means 7 into 1.0084 minus capital M means 14.00307 total atomic mass unit. That can be calculated. Delta M is equal to 0.10627 atomic mass unit. Now what is the amount of energy that is equivalent to 0.10627 atomic mass unit is the required binding energy. Means B is equal to 0.10627 into 931 mega electron volt, because one atomic mass is equivalent to 931 mega electron volt. Therefore 0.10627 atomic mass unit equal to 0.10627 into 931 mega electron volt. Does not require to delta m into c square. If delta m c square, then convert delta m into kg and take c is equal to 3 into 10 to the power 8 meter per second. Then you will get answer in joule. Then convert it into mega electron volt. But directly you can calculate mass defect into atomic mass unit. Just multiply 931 with the mass defect in atomic mass unit. You will get the required energy. Therefore, B equal to 0.10627 into 931 mega electron volt, that is equal to 98.80703 mega electron volt. This is the required answer of the binding energy in mega electron volt of nitrogen 7n14 nucleus to bind the protons and neutrons.